Fourth graders, today is Monday, September 30th, 2019, and we are finishing up the very short module, Module 2, with Module 2, Lesson 5, okay? And as you can see today, our learning goal says, I can use what I know about metric measurements to solve multi-step word problems. As you will recall, last week we spent a lot of time talking about different metric units. We learned how to use metric units to measure length. What is the basic unit that we use to measure length, or the distance between 2 points? Arnav? It's what? Length. That's called length, but what was the units that we used to measure length? Garrett? Meters. Good. We also talked about how we could use metric units to measure mass, or how heavy, or the weight of something. Avani, what kind of units did we use for that? Grams. Good. And last but not least, we learned that we could use metric units to measure how big something is, or how much space it takes up, or how much it can hold, and that's called capacity. What were the metric units of capacity? Evan?
Liters.
Liters, good. And so we learned that these are like the basic units, right? But we also learned that there are words that we can add to the front of these words, little short prefixes that can modify the size. What is a prefix that I can make meters, grams, or liters bigger in size? Anushka? Kilo. And how many times bigger does it make it? We remember that kilo means, Sanvi?
1,000.
It makes it 1,000 times bigger, right? Remember, when we move this way, it gets bigger. We also learned that there were some words that can modify those basic units to make them smaller. What's one prefix that would make meters, grams, or liters into a smaller sized unit? Kaship? Centi, yeah, like centimeter, good. And remember, when we move this way, it makes it smaller. How many times smaller is a centimeter compared to a regular meter? Haruto? 100 times smaller, good. And there was one more modifier, or one more word, that makes it a smaller size unit. Zara? Milli, yeah. Milli is another prefix. And how many times smaller is a milligram compared to a normal gram? Sparsh? 1,000. And we talked about last week how it's kind of like the place value system, where if this is the ones place, there'd be a tens place, a hundreds place, and the kilo is like the thousands place. Do you guys agree? Right? This is like the ones. And then over here, there'd be a tenths place, and this is like the hundredths place because it's 100 times smaller, and that's 1,000 times smaller. So it's kind of like the place value system because every time we move to the left, it's getting 10 times bigger. So let me ask you a question. How many times bigger is a kilogram compared to a milligram? Talk to the people at your table group. When we move from the milligram to the centigram, how many times bigger did it get? 10 times. Okay, what if I move to this column here? How many times bigger would it get? So totally, how much times bigger? 10 times 10, which is? Times another 10? Times another 10? Times another 10? Times another 10? How many times bigger is a kilogram compared to a milligram? 1 million times bigger. So you can see, remember, we learned that the metric system of units is exactly the same as place value because every time you move to the left, it gets 10 times bigger. So, your step number 1, you need to write the question down. How far did he bike on both days? Altogether, how much did he bike? The important information is that he biked this far, 1 kilometer, 125 meters on Monday, and on Tuesday he did 375 meters less than that. The directions also tell us we need to use a tape diagram, so that's important for us too. So let's go ahead and draw a tape diagram. On Monday, we know that he biked M for Monday. Sometimes when there's more than one tape diagram, I label them like that. We know he biked 1 kilometer, 125 meters. Now, right off the bat, we know we're probably going to have to convert that, right? So how many meters is that altogether? How many meters is that? Sornima? Good. So write it both ways so you can, okay? Then on Tuesday, T for Tuesday, should his tape be longer or shorter? Shorter, good. So draw a smaller piece of tape. And we don't know how far he biked on Tuesday yet, but we do know that this extra part is 375 meters. So how might I find out how much he biked on Tuesday? I could do 1,125 meters minus 375 meters, can't I? Can I? Yes, I can. Go ahead and do that math. Give me a thumbs up if you also found that he biked, instead of now question mark, we now know that he biked 750 meters on Tuesday. Give me a thumbs up if you got the same answer as me. So is that my final answer, 750 meters? Sanvi's shaking her head. Why not, Sanvi?
Because the question is asking how far did he bike all together.
We want to know how far he biked all together because it says on both days. So in order to do that, we have to add the distance for Monday to the distance on Tuesday. So we do 1,125 meters plus 750 meters. So find that all together, he biked 1,875 meters. But is that the simplest way to write the answer? No, because 1,000 of those meters is equal to, everyone? 1 kilometer. So your final answer should be 1 kilometer, 875 meters. Again, this is a two-step problem because for the first step, you had to first find out how far he ran on Tuesday, or biked, or whatever. And for the second step, you had to add them together to find the total. Okay, so again, this is a multi-step word problem because it has two steps. Zachary weighs 37 kilograms, 95 grams. Gabe weighs 4,650 grams less than Zachary. Harry weighs 2,905 grams less than Gabe. How much does Harry weigh? Okay, there is so many numbers and so many names here. Right off the bat, I'm like, whoa, this is too hard. I can't do this. I'm so confused. How many of you guys feel that way? It's okay. I feel that way when I see lots of numbers and lots of names and lots of information. But here's the thing. If we just slow down and RDW, read, draw, and write, it will become very easy. Let me show you. The first step is R, read. So what we have to do is write down what the question's asking. The question's quite simple. How much does Harry weigh? In the end, we want to find out how much Harry weighs. Okay, now that we know what the question's asking, let's identify the important information. It seems that there are three people. There's Zachary, who weighs this much, right? Then there's Gabe, who weighs this much less than Zachary. Last but not least, there's a guy named Harry. That's the guy we're concerned about. And he weighs this much less than Gabe. Okay, so now that we know the important information and we know that in the end we're trying to find out how much Harry weighs, we've done the R step. We've read the problem. Now what we need to do is draw a tape diagram. A tape diagram is the key that will unlock this problem and make it way more easy to solve. Since there are three people, how many tape diagrams do you think we need? 3, good. Let's draw one for Zachary. Z for Zachary. Zachary's is quite simple. We know that he weighs 37 kilograms, 95 grams. Okay. Now Gabe, G for Gabe, does he weigh more or less than Zachary? Everyone, more or less than Zachary?
Less.
Less. How much less? How much less? So let's cut off some of Zachary's weight. How much less? Sanvi?
4,650.
4,650 what?
Grams.
So you guys, as you're writing down the important information and labeling your tape diagram, get used to writing, force yourself to write the units because that is going to save you from making silly mistakes. Okay? So we don't know how much Gabe weighs, but it's this much over here. And the part that's missing is 4,650 grams. Okay, then there's a third guy named Harry. Does Harry weigh more or less than Gabe? Less. So let's draw it even shorter. Or let's draw one that's the same length as Gabe's weight, but let's cut off some of it because he only weighs this part of it, right? And how much less does Harry weigh compared to Gabe? Well, it says he weighs 2,905 grams less than Gabe. And in the end, we're trying to figure out how much Harry weighs.